Just give me a minute time. So what have we completed now? So what are we supposed to start with today? Yes. So I told you about magnification also, right? So next point is magnification of lens in contact. Okay. So we saw that there are two lenses of focal length f1 and f2 which are placed in contact with each other. Let's say the magnification produced due to the lens 1 is m1 and lens 2 is M2, then magnification due to lens 1 M1 will be equal to V1 divided by U, and the magnification due to the second lens M2 will be equal to V divided by V1, right? And the effective magnification M effective is equal to V1 M effective is equal to V divided by U, where V is the final image, U is the initial distance. So M effective, if I write it as V divided by U, this can be written as V by V1 into V1 by U. And V by V1, we know it is a magnification produced due to the lens 1 into V1 by U is a magnification produced due to the second lens. So the effective magnification when the lenses are in contact with each other is going to be product of individual magnifications. Shall we proceed? Now, the next concept that we are going to discuss is lens formula. So basically, if you take a lens of this form, that is, if you take a convex lens and with respect to the convex lens, you have the focus, the center of curvature. Similarly, you have the focus and the center of curvature. If you place an extended object AB beyond the center of curvature, then when a ray is considered parallel to the principal axis, after refraction would pass through the focus. Similarly, when you take a second ray through the optical center, then after reflection, the ray would pass undeviated. So that the final image is formed at the space which is called as A dash B dash. So from this point, if I drop a perpendicular, let me call this point as M. Now, if I drop a perpendicular, then I need to find two sets of similar triangles. So for that, if I take the triangle BAO, then O to A is the object distance and O to A dash is the image distance and O to F is going to be the focal length. So if I take OA, that is going to be U and AB is written as it is. So this triangle, I can say it is similar to the triangle A dash B dash O, or I can say B dash A dash O. Now this distance will be B. So what we can conclude is triangle BAO is similar to triangle B dash A dash O. Then we can write B dash A dash divided by BA is equal to A dash O divided by AO, which implies B dash A dash divided by BA is equal to, what is A dash O? A dash O is B and AO is minus U. So let me call this as equation number 1. Similarly, if you look at the triangles MOF, if you look at the triangles MOF and B dash A dash F, B dash A dash F, then we can say that F is same because it is vertically opposite angle and angle O is equal to angle A dash because they are 90 degrees. So according to AA criteria, they both are also similar. So we can say B dash A dash divided by MO is equal to A dash F divided by OF. So what is B dash A dash by MO? Which implies B dash A dash divided by, if you observe the diagram, MO is exactly the same as that as BA. So divided by BA is equal to A dash F divided by OF. So what is A dash F? If you observe what is A dash F, it is V minus F. So A dash F is V minus F and OF is small f. So A dash F is V minus F divided by OF is F. So let me take this to be equation number 2. So B dash A dash divided by BA is minus V by U. Also, it is equal to V minus F divided by F, which implies minus VF is equal to UV minus UF. So rearranging the equation, we get UF is equal to UV plus VF. Now dividing with UVF on both sides, we get UF divided by UVF is equal to UV divided by UVF plus VF divided by UVF. So UF and UF get cancelled. So 1 by V is left out is equal to UV and UV get cancelled. 1 by F is left out plus VF and VF get cancelled, which is 1 by U, which implies 1 by V minus 1 by U is equal to 1 by F. And this is what is called as lens formula. Magnification of a lens. So when you see magnification, here again I'm trying to talk about linear magnification. So linear magnification is defined as ratio of size of image to the size of object. So size of image is B dash A dash divided by size of object is BA. This is equal to M. Right? Now, if I say B dash A dash is height of the image and BA as height of the object. If you observe B dash A dash in the diagram, if you observe B dash A dash in the diagram, it is negative because it is inverted. So it is minus HI divided by BA is going to be H naught is equal to M. So let this be equation number 3. But from 1, we know that B dash A dash divided by BA is equal to minus V by U. But what is B dash A dash by BA? It is minus HI divided by H naught. So minus HI divided by H naught is equal to minus V by U. Minus and minus will get cancelled, which implies height of the image divided by height of the object is V by U. This is magnification, and the magnification is given as V divided by U. Is this point clear? So this is all about magnification produced due to a lens. Okay. Today, so there is only optical instrument that is left out. By next class, we can complete it. But before that, I want you to concentrate on few problems today. So we'll start concentrating on these problems. So today you are going to work. 41. So there is a small air bubble in a glass here of radius 2 centimeter and appears to be 1 centimeter from the surface when looked at. the refractive index of the glass is 1.5, find the true position of the air bubble. Sorry? How much is it? Two by three. Both answers are not right. Are you using apparent aperial depth? Don't use that. But that is for a flat surface. Here you have a circular option. If you draw a proper ray diagram, you get the answer. The hole, the small air bubble. The air bubble appears to be at a distance of 1 centimeter from the surface, provided you look along this direction. You look along the diameter of the surface. Wait, draw the diagram. The only hint I can give you is the problem is based on refraction at spherical surface. You see, the problem is actually only one step. Get the right diagram, you get the answer. Can you show your diagram? How much is it? 4 by 7. Those who are online are able to listen. You read the question carefully. You have a sphere, right? This is the diameter of the sphere, right? So this is the center. If I call this as, I'll call the center as C for instance. Okay. So your eye is here, for instance. You're looking along the diameter. When you look along the diameter, where is the object found to be? It is appearing as if it is at a distance of 1 centimeter from the surface. Means this is the, let us say, the hole is here. Okay. If a ray is traveling like this, then at this point you will draw the normal. The ray is traveling from denser to rarer medium, so it starts bending away from the normal. So when it comes, this is what is that 1 centimeter. But they are asking what is the true position of the object. This is X. And you know, from center to the surface, it is 2 centimeter. So apply the formula. If this is mu1, This is mu2. Mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by r. So mu2 is how much? Mu2 is how much? 1 by mu2 is not 1.5. Mu2 is the place where the image is formed. 1 by minus v. So outside medium is having refractive index 1. And where is the image formed at a distance of minus 1 centimeter? Is equal to mu1, sorry, minus mu1 is 1.5 divided by minus, actually you should not take minus u. So for whichever is unknown, you should not take sign convention. Is equal to mu2 minus mu1 divided by r. R is minus 2. So minus 1 minus 1.5 by u is equal to minus 0.5 by 2. So minus 1 plus 1 by 4 is equal to 3 by 2u. So you will get 3 by 4 is equal to 3 by 2u. Sorry, minus 3 by 4 is equal to 3 by 2u. So this and this will get cancelled. Minus 0.5. 1 minute. mu2 by v. V is minus 1. Is there any calculation mistake? I think that is the answer. Minus 1 minus 1.5 by u is equal to where? This will come this side, no? Plus 1 by 4 is equal to 1.5. I wrote it as 3 by 2. So 3 by 2u. Correct only, no? So minus 1 plus 1 by 4 is minus 3 by 4 is equal to 3 by 2u. 3 and 3 are gone. U is equal to minus 2. U is equal to minus 1 by 2. 0.5 should be the answer. But O is taken this side, no? There is some calculation mistake. No? So minus 1 minus 1.5 by u is equal to 1 minus 1.5 divided by, there is a mistake I made. There is minus, no? 4 by 5 is right, I think. 4 by 5 is how much? 5 by 4. So minus 1 or 1 plus 1 by 4 is equal to 3 by 2u. So 5 by 4 is equal to 3 by 2u. Cancel 2 times. So u is actually 6 by 5. Not 6 by 5 is 1.2 centimeter. So the mistake I made is I wrote minus here, but I forgot to write the minus in the below. Okay. Is that clear? Or else you will not be able to know where the position is. mu1 is always the point. mu1 is always refractive index of the medium where the object is placed. So first, if you fix that, mu2 will be the place where the image is formed. You can ask me. In this case, the image is also formed in the same medium. But what is priority? Where the object is there. So, yeah. The image is formed because it's forming a virtual image. What if it was the image on the other side? நான் சொல்ல புரியுதா? இமேஜ்னால ஆப்ஜெக்ட் will not change. Object's position is fixed. அதனால ஃபிக்ஸ்டா இருக்கிறதுக்கு மட்டும் தான் mu1 எடுக்கணும். So example 442. An empty spherical flask of diameter 50 centimeter is placed in water of refractive index 4/3. A parallel beam of light strikes the flask. Where does it get focused when observed from within the flask? So read the question carefully, we get the answer. So first draw a flask. So what shape does the flask take? It's spherical in nature. An empty spherical flask. An empty spherical flask is placed. Okay. And the diameter of the flask is 15 centimeter. It is placed in water of refractive index 4/3. A parallel beam of light strikes the flask. Where does it get focused? So when you take a parallel beam of light along the principal axis, focus. No? But what kind of a surface does it form? Is what it is. Is it forming a concave surface or a convex surface? When the spherical flask is bulged outside, is it going to form a concave surface or convex surface? So for convex, it should form a virtual image because it get diverged. Answer remains the same. So listen to this. There is an empty spherical flask of diameter. So there is a spherical flask of diameter 15 centimeter. Okay. And this whole flask is placed in a medium whose refractive index is 4/3. So when they say empty spherical flask, what is the medium here? Is it not air? Right. So when a ray strikes parallel to the principal axis, observe when the ray travels from denser to rarer, what will happen to it? It starts bending away from the normal. So here also it starts bending away from the normal. So where do they get focused? These two rays put together will form an image at point I on the left hand side. So you are observing from within the flask. Your eye is here. Okay. Now tell me, mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by r. What is mu2 by v? That's what we need to find. But what is mu2? Mu2 is how much? By 3/2? Air, no. 1 by v minus mu1 is 4/3. How much is u? Yes. Is equal to mu2 minus mu1. So 1 minus 4/3 divided by r is how much? 15/2 plus 15 no by 2. Is it positive or negative? Positive because it is on the right hand side. So this value will be 0. 1 by v is equal to minus 1/3 divided by 15/2. Why? You don't know whether it is, whichever is unknown, you should not apply it. It's only rough diagram. 45/2. Which sign? Did you get a negative sign? Wait, the charge is over. 45/2 is the right answer with the negative sign, minus 22.5. Vedra? So it is in the left side medium. 4/3 தான் எடுத்தேன். U1 is 4/3. U1 is the place where object is there. கீழே denominatorல என்ன இருக்கு? U இருக்குல்ல, அதான் hint. Try this. Get used to drawing. See, plane boundary, I'm sure you can handle it. Otherwise, you will make mistakes. So concentrate. A sunshine recorder globe of 30 centimeter diameter is made of glass of refractive index mu is equal to 15. 15. Diamond is 2.4. 1.5. A ray enters the globe parallel to the axis. Again, the source is at infinity. Find the position from the center of the sphere where the ray crosses the axis. First, see, don't overthink. Globe man is spherical. First, draw a sphere of radius 15 centimeter. Okay. It is made of glass. A ray enters the globe parallel to the axis. Draw parallel to the axis. Find the position from the center of the sphere where the ray crosses the axis. Because the ray is parallel to the principal axis, where will they meet? At a point on the principal axis. Question clear about it. Find the position from the center of the sphere where the ray crosses the axis. Center okay. You will always find the image distance from the surface. Surface find the image distance subtracted from the radius. The other side measure. I don't. Let's check. So there is a glass sphere of radius 15. Okay. Refractive index of the glass. So mu is 1.5 and outside medium is 1. So there is a ray which is parallel to the principal axis. You take two rays, that is enough. After refraction, they tend to come and meet somewhere over here. Okay, let me call this as the center. And this is the point where the image is formed. So how much is the image distance? Mu2 by V. Mu2 is how much? 1.5 by V minus 1 divided by infinity is equal to mu2 minus mu1 divided by R. R is how much? 15. So 3 by 2V is equal to 1 by 30. This goes 15. So V is equal to 45 centimeter. But this V is measured from where? From the center. So from the center, it is actually forming at a distance of 45 centimeter. 45 now, where is it? It is not happening within the sphere. It is happening this side. So from the center, how much is this distance? This is already 15. This is how much? This is also 15. So answer will be 36. 30 should be the answer. Let me check what is the value. Denser to rarer, rarer to denser. They've given 22.5. Here's the position where the image is formed. Okay, 45 centimeter. Actually, we made a mistake. See, the logic is this 45 centimeter is appearing because of the 45 centimeter is appearing because of the first refracting surface, right? So this 15 centimeter will start acting as the object for the second refracting surface because it undergoes two refractions. Okay, so you need to apply the same formula again in the sense mu2 by v minus mu1 by u is equal to mu2 minus mu1 divided by r. This time, what is going to be mu2? It will be 1. 1 divided by v minus mu1 is how much? 1.5 divided by what is the value of u this time? It is u is plus 15. U is plus 15. Why 13? It's always measured. U is always measured from the surface. 15 then, so 15 is equal to mu2 minus mu1. That is 1 minus 1.5 divided by, with respect to the second refracting surface, what is the radius of curvature? It is minus 15. So 1 divided by, this is v dash. Okay. So 1 divided by v minus 1 by 10 is equal to minus 0.5 divided by 15. That is minus 1 by 30. So 1 by v is equal to 1 by t, 1 by 10 plus 1 by 30. How much is it? Correct only, no? 1 by 10 minus 1 by 30. Yeah? So 20 divided by 300. So v will be equal to, yeah, or same mistake again. Up 1 by 30, applying plus 1 by 30. 40 divided by 300. Is it correct? Rendu one danda. But 7.5 is from where? 7.5 is from the surface. But they asked from the center. So center na 15 more will get added to the 7.5. So V will be equal to 15 plus 7.5, which will give you 22.5 centimeters. This is a good problem. Okay. Shall we do another one? Now let's do problems based on lens maker's formula. Find the radius of curvature of the convex surface of a plano-convex lens whose focal length is 0.3 meter and the refractive index of the material of the lens is 1.5. That's it. 10 by 6. Sir. What are they asking? Radius of curvature. Will you use the proper sign convention? What is the formula? 1 by f is equal to u. 1 by r. Okay, that's it. When you take the let me check it. Find the radius of curvature of the plano-convex surface. So 1 by f is equal to refractive index of glass divided by refractive index of outside medium minus 1 into 1 by r1 minus 1 by r2. So 1 by f is equal to refractive index of glass is how much? 1.5. Outside medium is 1 into 1 by infinity minus 1 by depends on which side you're taking. So whose focal length is 0.3. So focal length of a convex lens, is it negative or positive? So plano convex. So for which focal length will be negative? So minus 0.3. So 1.5 minus 1 is half. Half into 1 by 0.3 is 10 by 3. Engada 1 by r. Oh, whose focal length is already given. Sorry, I made a mistake. 1 by r. This side it will be minus 1 point. Correct? Now is it fine? So minus 10 by 3 is equal to half into minus 1 by r. So minus and minus will get cancelled. 20 by 3. 20 by 3. 3 by 20, correct? Which implies r is equal to 3 by 20 or 0.3 divided by 2 or 0.15 meter, which is also equal to 15 centimeters. Those who are online are able to understand?
Yes, sir.
Yes, sir.
Good. There is a convex lens of focal length. There is a convex lens of focal length 0.2 meter and made of glass whose refractive index is 1.5. Now it is immersed into a medium of refractive index 1.33. Read the question carefully. Find the change in focal length. If change is final minus initial. Good. So convex lens of focal length 0.2 meter, refractive index of glass is 1.5, and refractive index of medium is 1.33. So 3/2 and refractive index of medium is 4/3. So this is f. F dash is equal to how much? So 1/f is equal to 1.5 divided by 1 minus 1 into 2/r. And 1/f dash is equal to, I'll check that, 1.5 divided by 1.33 minus 1 into 2/r. Why I wrote it as 2/r is because 1/r1 minus 1/r2 is there, right? I considered it to be equifocal. So 1/r minus of minus 1/r because of sign convention. So if I divide both, then I'll get f dash divided by f is equal to 2/r and 2/r are gone. 1.5 minus 1 is half. 1.5 by 1.33 is how much? 3 divided by 2 by 4/3, which is 9/8. Which is 9/8. It will go 4 times. So it will be 4/9 times. So f dash will be equal to 4/9 times f, which is 0.2. So 0.8 divided by 9. So what is f dash minus f? 0.8 by 9 minus 0.2 minus 1 divided by 9. So change in focal length is going to be minus 1 divided by 9. Okay. We'll do one last problem. If the refractive index from air to glass is 3/2 and that from air to water is 4/3, find the ratio of the focal length of glass lens in water and in air. Where is it? Glass lens in water and glass lens in air. It's 3/2. If the refractive index from air to glass is refractive index of glass with respect to air is 3/2. Similarly, air to water means refractive index of water means absolute refractive index of water is 4/3. Find the ratio of the focal length of the glass lens in air, in water and air. So 1 by focal length of lens in water is equal to mu g divided by mu a minus 1 into 2 divided by r. We don't know what length it is. They didn't give it, so we'll assume it to be convex. 1 by focal length in air is, mu g divided by mu air minus 1 into 2 by r. Divide both. Okay. Fa divided by Fw is equal to mu g by mu w is how much? Mu g is 3 by 2, mu w is 4 by 3 minus 1 divided by, this is 3 by 2 minus 1. So how much will this be? 9 by 8 minus 1 divided by half, which is so Fw by Fa will be 4. That's the answer. Clear? So those who are online, I hope you're clear, right?
Yeah, yes, sir.
Yes, sir.
Okay, then we'll wind up. See you all on Monday. Monday we'll discuss about optical instruments and we'll finish them.
Thank you, sir.
Yeah.
Thank you, sir.
Okay. They asked you the refractive index of lens in water and air. Glass lens. It's a glass lens which is placed in water and air. ஒன்றும் இல்லை, நான் போட்டிருக்கேன் ஸ்பெக்ஸ் ஏதான் கிளாஸ் ஏர்ல என்ன இருக்கும், தண்ணியில போட்டா என்ன இருக்கும். Okay.